Welcome, friends. Have you ever imagined a solid wall in your room suddenly transforming into a transparent glass window? And I'm not talking about a normal TV screen or projector here. I am talking about an invisible illusion that is 99.9% accurate. If you step forward, the view outside gets wider. If you look left, you see the right side, exactly like a real, physical window. Standard screens fail because they lack the parallax effect. But this AI system solves that using an incredible mix of hardware and software. Every screen we see today, no matter how high the resolution is fundamentally 2D. When you walk past a screen, the depth and shadows don't match your physical movement, which instantly tells our brain that it's fake. But today, we are going to decode a revolutionary concept. The Gaussian Spatial AI Window, proposed by me, Shivshankar Kumar, better known as Shiva Shourya or AlienX Shourya. It starts inside the room. Invisible infrared cameras track your exact eye position in 3D space with zero latency. Simultaneously, on the outside of the building, an array of LiDAR and high-speed cameras scan the real world in real time. This hardware combination creates a live data pipeline, passing the outside world to the brain of the system, the spatial computing engine. This is a massive paradigm shift in the field of spatial computing. This isn't just a screen, it's a live digital twin of the outside world. So let's understand the mind-bending science and technology behind it. Friends, to create such a perfect illusion, no ordinary computer will do. Running in the background of this window is a high-performance hardware infrastructure. First, it uses the NVIDIA Blackwell GB200 superchip. Why? Because it has to process millions of data points in real time. The display used is a 10,000 nit micro LED screen. This is bright enough to easily compete with natural daytime sunlight. And it has zero bezels or borders, so your brain doesn't perceive it as a standard television. To capture the outside world, solid-state LiDAR and 8K stereo cameras are deployed. On the inside, looking at you, are infrared pupil tracking cameras that track your eyes 120 times per second, 120 Hz. But how does all this hardware work together? There are some fundamental technologies behind this. Let's understand them carefully. Technology number 1. Unified Gaussian environment. Older 3D games used stitched polygons. But this AI window uses Gaussian splatting. The environment is made of millions of 3D blobs. Each holds data for position, transparency, and view-dependent colors. But rendering this entire city every millisecond is too heavy. So to save processing power, the system permanently loads all the Gaussians of the non-moving environment into memory. This is called static caching. Next, to save GPU memory, the system only renders the Gaussians in the exact direction you are currently looking. This is called frustum culling. The job of this engine is to render the static world, like trees and buildings. But the world outside a real window doesn't stand still. People walk, cars drive by. Because the static background is safely cached in memory, the system has the power to run technology number 3, dynamic Gaussian injection. The exterior cameras capture live data, convert moving objects into 4D Gaussians, and inject them into the digital world within 5 milliseconds. A deformation field algorithm calculates the rotation and movement frame by frame without any visual glitches. Now we come to the most crucial part. Normal TVs assume you are sitting exactly in the center of the screen. But in front of a window, we move around. This is solved by asymmetric frustum projection. It calculates the distance between your eyes and the screen, flattening the 3D volume to give you 100% natural parallax. But if there is even a 20 millisecond delay between your eye moving and the screen updating, your brain will realize it's a screen and you might feel motion sick. To prevent this, the AI window uses predictive rendering and massive parallel processing, which is called parallel predictive Kalman filtering. It literally calculates where your eyes are going to be in the next few milliseconds and renders that view in advance. This ensures a buttery smooth 120 frames per second experience, completely tricking the human brain into believing it's real. But creating 3D objects isn't enough. For a perfect illusion, the lighting inside your room must match the digital world outside. The Gaussians use something called spherical harmonics. This math calculates exactly how sunlight or street lamps should bounce off surfaces. This ensures that every dynamic object injected into the scene perfectly matches the ambient lighting of the real world. All this heavy processing is sent to an ultra-high brightness, bezel-less micro-LED display panel. Micro-LEDs offer perfect blacks and blinding brightness, completely erasing the screen door effect so it feels exactly like glass. The system renders the image for that future coordinate, creating a zero-lag experience. A complete cycle runs every 15 milliseconds. To prevent screen glow, the system uses true light display synchronization. It reads the ambient lighting inside your room and adjusts the display's colors to look like a natural part of the wall. It even learns ambient light over weeks for hyper-realistic dawn and dusk states. The best part? Because it's an AI-driven digital canvas, you aren't limited to the street outside your building. You can stream real-time Gaussian environments from anywhere on Earth, or even entirely fictional sci-fi worlds. It essentially makes physical location completely irrelevant. The world becomes a customizable wallpaper. Building this requires an orchestra of hardware engineering, real-time AI, and advanced geometry. But the final product is so seamless that all the complex mathematics disappear, leaving only magic. This is the future of interior design. Windowless rooms, underground offices, or hospital wards with no natural light. This system can bring the outside world anywhere. It's a masterstroke of high concurrency hardware, neural networks, and ocular telemetry that will transform physical walls into platforms of digital transparency. How do you think this technology will change our lives? Let me know your thoughts in the comments below. If you found this video informative, hit the like button and share it with your friends.
सोचो अगर दीवारें हवा हो जाएं, जो नजरों के सामने है वो धुआं हो जाए। ये ख्वाब नहीं, एक नई शुरुआत है। एलियन शौर्या की ये छोटी सी सौगात है। ना लाइट मुड़ेगी ना फिजिक्स रुकेगी, बस तुम्हारी नजर अब वही देखेगी जो मैं दिखाऊंगा, जो मैं दिखाऊंगा, जो मैं दिखाऊंगा, जो मैं दिखाऊंगा। ये जादू नहीं, बस नजरों का खेल है। विज्ञान और सपनों का ये सुहाना मेल है। परसेप्चुअल इल्यूजन एक नई दिशा, गायब होने की पूरी होगी अब हर त्रिशा। ये जादू नहीं, लॉजिक है दोस्तों। लॉजिक है दोस्तों। तुम कहाँ खड़े हो ये सिस्टम जानता है। तुम्हारी हर नजर को ये पहचानता है। पीछे की दुनिया को आगे ले आता है। ओले की चादर में सच छुप जाता है। एक दबवा जो खली है पर भरा है राज से। दुनिया बदल देंगे हम इस अंदाज से। बंद कमरे में विंडो खुलेगी, बिना तोड़े दीवारें बाहर की रोशनी मिलेगी। ऑफिस की वॉल्स अब होंगी इनविजिबल, प्राइवेसी भी होगी और नजरें भी विजिबल। डर को मिटा के जब ब्रिज पे चलोगे, हवा में तैरने का एहसास करोगे। और वो इनविजिबल सूट जो पहने गायब हो जाए, हैरी पॉटर की दुनिया अब सच हो जाए। ये फ्यूचर खड़ा है दरवाजे पे आके, बस एक कदम बढ़ाना है हाथ बढ़ा के। और इन दीवानों क्या तुम सुन रहे हो, मेरे साथ क्या तुम ये सपना बुन रहे हो। कोलैबोरेट करो चलो साथ चले, एलियन शौर्या के संग नए दीप चले। जादू नहीं ये लॉजिक है, ये लॉजिक है, ये लॉजिक है।